Hi, my name is Ananda Hasanah and I am from Mathematics Education at 11 Maret University. And today we will learn about arithmetic progression and geometry progression. But before we start, let's sing along with me to boost our motivation to learn mathematics. In my count, 3, 2, 1. I hope that you all have better motivation now. The first one is about arithmetic progression. What is arithmetic progression, or we usually call it as AP, is sequence of number in which for every pair of consecutive terms, the second number is obtained by adding the fixed number to the first one. The notation of arithmetic progression is common difference, or T, nth term an, and sum of the first nth term is Sn. The first one is about common difference, or T. What is T? T is if the progression is A1, A2, A3 until An, the T is A2 minus A1 equals with A3 minus A2. So the formula for the T is An minus An minus 1, where the T is common difference. It can be positive, negative. We mentioned before about A. What is A? A is the first term of the progression. So A equals with A1. And in arithmetic progression, we have two main formula. The first one is n terms, and the second is sum of the first n terms. We will learn the n term first. The n term of arithmetic progression have formula a plus n minus 1 times t, where the a is the first term and t is the common difference and n is the number of terms. For example, if the progression is 1, 3, 5 until an, and the number of terms are 10, so the a10 or an or the last term is for the formula an is a plus n minus 1 times t, and a is the first term is 1, and common difference t is we get from 5 minus 3 equals with 3 minus 1. So the common difference, or t, is 2. And we know that n is 10, so the a10 is 1 plus 10 minus 1 times 2 equals with 1 plus 9 times 2 equals with 1 plus 18. So the a10 is 19. And then the second example, in the performance building, seats are arranged with 14 in the front row, 16 in the second row, 18 in the third row, and so on, always increasing by 2. And how about the 20th row? How much seats in there? From the question, we know that A1 is 14 and A2 is 16. And the question is number of seats in row 20, or we call it as A20. And from the formula is a plus n minus 1 times t, and the a is the first term, so a is 14, and the common difference, or t, is we get from a2 minus a1, so 16 minus 14 is 2. The common difference is 2. So we could find the a20 from there. So it just substitution the the variable into the formula. So we get A20 is 14 plus 20 minus 1 times 2, 14 plus 19 times 2, 14 plus 38, and then finally A20 is 52. So the number of seats in the 20th row is 52 seats. And then the second main formula is sum of first n terms, or we call it as Sn. The formula of Sn is a half of n times in bracket to a plus n minus 1 times d. Or we mentioned it before, but that an is a plus n minus 1 times d. So the Sn, it can be shown as a half of n times in bracket a plus en. So for the example of adding natural numbers up to 15 numbers. So the progression is 1, 2, 3, 4, 5, 6, 7, 8 until 15. And given a is 1, t is 2 minus 1, 1, and an is 15, n is 15. Now from the formula, we know that Sn equals with a half of 2 times in bracket to a plus n minus 1 times d. So we know all the variable, it's just substitution to the formula. We get S15 is 15 divided by 2 times 2 times 1 plus 15 minus 1 times d. So from the calculation, we know that S15 is 120. So the sum of the first 15 natural numbers is 120. The second example is about story question. The question is, an iron is cut into 5 parts, thus forming an arithmetic sequence. If the shortest length of the iron is 1.2 meter and the longest is 2.4 meter, then the length of the iron before cutting is. From the question, we know that A or A1 is 1.2 and A5 or AN or the last term is 2.4, and the question is S5. So the solution from the formula we get before, S5 is a half of 5 times 1.2 plus 2.4. So the S5 is 9. The length of the iron before cutting is 9 meters. And then we move to geometric progression. And what is geometric progression? Geometric progression is a sequence in which each term is varied by another by a common ratio. The next term of the sequence is produced when we multiply a constant which is non-zero to the preceding term. The general form of geometric progression is AR square, AR to the power of 3, and so on until AN, where the A is the first term, R is common ratio, and AN is n terms. We get common ratio from the any term divided by preceding term. So the AN divided by AN minus 1. From the general form, we know that A1 is A, the second term is A2 is A times R, AR, and the third term is A2 times R, the A2 is AR, so A3 is AR square. Similarly, the nth term is a times r to the power of n minus 1. So the formula to find the nth terms in geometric progression is a times r to the power of n minus 1. And then the second main formula is sum of first and term in geometric. In geometric, we know that two types of that. The first one is finite geometric progression, and then the second one is infinite geometric progression. In finite geometric progression, the general form is ar square, and so on until a times r to the power of n minus 1. But in infinite geometric, the general form is ar square, and so on until a times r to the power of n minus 1, and so on. And the sum of the finite geometric progression is Sn, so equals with a times in bracket r to the power of n minus 1 divided by r minus 1 if the r is not 1. But if r is 1, the Sn have the different formula. The Sn is n times with a. But for the infinite geometric progression, the formula is also different. The sum of infinite geometric series is S equals with a divided by 1 minus r. For this example, it is known that a geometric series 36 plus 24 plus 16 plus 32 divided by 2 and so on until plus 512 divided by 143. The question is determine the value of the sixth term. The second question is determine the number of term, and the third question is determine the sum of n term. We will answer the first question first. But before that, we know that first term or a is 36 and common ratio or r is a2 divided by a1, so 24 divided by 36, so we get r is 2 divided by 3. And then we know that the last term is 512 divided by 143. And then the first question is value of the sixth term. So we will find the a6. From the formula, we know that a times r to the power of n minus 1. So we get 36 times 2 in bracket 2 divided by 3 to the power of 6 minus 1. So from the calculation that show is we get a6 by 128 divided by 27. So the sixth term is 126 divided by 27. And then the second question is about the number of term, or we call it as n. From the question, we know that an is ar n minus 1. So the an is 512 divided by 143. So the a is 36 and r is 2 divided by 3. So from the question, finally we get that 2 divided by 3 to the power of 7 equals with 2 divided by 3 to the power of n minus 1. So 7 equals with n minus 1. So we get that n is 8. And the number of terms are 8. The third question is about the sum of the term. We know that the n is 8, so we will find the S8. The Sn formula is A times in bracket R to the power of n minus 1 divided by R minus 1. So we get that S8 is 36 times in bracket 2 divided by 3 to the power of 8 minus 1 divided by 2 divided by 3 minus 1. So we get that the finally we get that the S8 is 25,220 divided by 243. So the sum of the term is like that. I think that's from me. If you have any question, you can contact me through below in my email in Ananda Hasanah 03@gmail.com. See you. Thank you for your attention.